Now let's take a look at basic Layer 2 bridging and switching operations. Here we have a switch with 4 devices attached, device A, B, C, and D. For simplification purposes, we're going to summarize the MAC address of each device simply by saying AA, that's the MAC address of A, and BB, C, and D, etc. Here, initially, when the switch is first powered on and devices are first plugged in, the switch's MAC address table is empty. Device A sends out a frame to device C. Here's the source address, destination address. Device A sends a frame to C. The frame comes in on port 1, and the switch looks at the destination address here. The switch compares that destination address to entries in its MAC address table. Since there are no entries here, the switch recognizes this as an unknown or unrecognized destination MAC address. Switches flood all frames to unknown MAC addresses, which means that the switch takes a copy of that frame and floods it out of all ports other than the one that it came in on. In addition to this, the switch learns the MAC address of the source device from the source address field here, associating that address with the port that it came in on. After device C sends a response to device A, now this frame will be compared, the destination field will be compared to the entries in the table. Notice now there's actually an entry for A's MAC address here, and so now the switch knows that it can take this frame and forward this frame out of port 1. At the same time, the switch does something called filtering, which means that the switch is not going to send that frame out of the other ports where you've got device D and where you've got device B. So it will forward it out of port 1, but it will not forward it out of the other ports, of course, nor will it forward it out of port where C is attached to. In addition to that, of course, the switch learns the source address of C and associates that with the port that C is attached to. Eventually, the switch will learn all of the MAC addresses and associate them with the appropriate ports. If either of these devices sends out a broadcast, and I'll just sort of abbreviate that with a bunch of F's, at layer 2 there's a sequence of hexadecimal F's in the destination frame field here for a broadcast address. The switch does the same thing that it did with all of the previous packets. These were unicast packets right here, and this is a broadcast packet. However, the switch still operates the same way. The switch will take this destination field and compare it to the entries in its table. If there is no match in the table, the switch does the same thing that it did before. It does not recognize the destination address, so therefore the switch floods the frame. This is the reason for the behavior behind the way that broadcasts are sent. Switches are considered to have all devices in one broadcast domain because if a broadcast is sent, then that broadcast would be sent to every device on the entire network. This is called being one broadcast domain. The thing to keep in mind here, it's not because it's a broadcast, but because it's an unknown or unrecognized address that the switch is actually doing this behavior. So it's not the behavior that we want to focus on, but it's the actual addressing here that makes this a broadcast. So that's a basic look at layer 2 switching.